All right, number one, the homework. I've already defined X and Y for you on the template. X is going to be necklaces, Y is going to be earrings. So on your template, X is the number of, what did I just say? Necklaces. Y is the number of earrings. I think that has 2 R's in it. All right, now we're looking for phrases that limit the number of earrings or necklaces. And as we read the problem, there's several. Mackenzie can make between 10 and 25 necklaces. So that's a phrase, between 10 and 25 necklaces, that we need to address. Between 10 and 25 necklaces. Right after that was a phrase that said something about between something and something earrings. Between 15 and 40. Between 15 and 40. Earrings. And there's one more phrase. As you read through it, it's a little bit further down. It's not about profit. She plans to sell at least 30 pieces of jewelry. That's another phrase that restricts her production. You got to have enough jewelry to add up to be 30 pieces, okay? And pairs of earring only count as one. That's something I should have addressed a long time ago, but a pair of earrings is just going to count as one thing sold, okay? So at least 30 pieces of jewelry. The last 2 pieces of information from the word problem, $3 profit for earrings and $5 for necklace. That goes over on the other table because it's talking about profit. It's talking about money. So $3 per earring, $3 per pair of earrings, and $5 per necklace. All right, now we've got all the information where it needs to go. We just need to write an inequality for each phrase. This is where it's differentiated. Some people are just completely comfortable with this, and they just start writing inequalities. They don't need any help. Others need a little push in the right direction. And what I call this is the concrete example. Pick a number of necklaces and a number of earrings, and let's see if it fits. Okay? Now we're going to do reasonable numbers, and we're going to pick numbers that aren't already in the problem. For example, 20, somewhere in the ballpark. 30, somewhere in the ballpark. 20, 30. And then one at a time, we're going to look at each phrase. And we're going to use the numbers 20 and 30 to play with the phrase. You ready? First phrase. Between 10 and 25 necklaces, is our 20 okay? You're saying yes, and that's fine. But the yes or no part is not important. It's not important. It's what did you do? In your mind, you did this. You said 10, 20, 25. You checked to see if 20 was bigger than 10, but smaller than 25. Agree? Didn't your mind tell you it's between 10 and 25? Right? So I'm just writing that down on paper. 20 is between 25 and 10. So 10 is less than or equal to 20, which is less than or equal to 25. That 20 represents X. So your inequality, 10 is less than or equal to X, which is less than or equal to 25. What about the 30 earrings and the phrase? Is that okay? 30 earrings? Somewhere between 15 and 40. Is that okay? Yeah, it's okay. But you said yes because you were looking at a 15, looking at a 30, looking at a 40. In your mind, you're looking at them that way. Is 15 smaller than 30, which is smaller than 45? So for any number of earrings, that 30 represents Y. So 15 is less than or equal to y, which is less than or equal to 40. And then the last phrase for the inequalities, is that enough pieces of jewelry? And again, we're going to count earrings as just a set of earrings. Is 20 necklaces and 30 earrings enough to need at least 30? All right, you're saying yes. What are you doing in your mind with the 20 and the 30? And I messed up. I picked a number that's in the problem. I shouldn't have done that. The red 20 here represents necklaces. The red 30 represents earrings. You're adding them, and you're checking to see if they are at least 30. I'll use blue. At least greater than or equal to 30. Because that 30 that's in blue came from the phrase 30, right? I messed up. I should have used a different. Try to avoid numbers in your concrete example that are already in the problem for that reason right there. Okay? But anyways, the 20 represents x, the 30 represents y, so your inequality, x plus y, has to be greater than or equal to 30. Figure out that this McKinsey, the business would have just made with 20 necklaces and 30 rings. What you made. Take your calculator if you need to. 20 necklaces, 30 earrings. How much money did you just make? What you got? Was it 190 bucks? How do you come up with that number? What are you doing with the 30 earrings? Aren't you multiplying the 30 earrings times 3? $3 each? What about the 20 necklaces? You're multiplying it times 5, and then you're adding those two answers. Remember, your 20 is x, your 30 is y, 5x plus 3y. That's a function that will find your profit no matter how many necklaces or earrings you sold. That's learning target 11. It's done. The rest of this is learning target 10. But you would need to take all of these inequalities you just wrote and graph them, find the corners of the feasible region, and plug them into the function that you just wrote and make a table. Okay, we're going to finish it together in class, but I'm going to stop the video. One last thing before I do stop the video. Why are we not putting our logicals on this inequality? Well, you put logicals, which mean x is bigger than 0, y is bigger than 0, if there's not already one that says that. So look at your first one. 10 is smaller than x, which is smaller than 20. Does that mean x has to be bigger than 10? Then you don't need x is bigger than 0 because it's already covered. Y, your second inequality tells you y has got to be bigger than 15 already, so you don't need a y is bigger than 0. All right, so I'll stop the video and we'll finish it in class.